All right, today we're going to be talking about writing linear equations from word problems. Last time we really focused on writing linear equations based on different situations, given different points, different kinds of descriptions, and today we're going to really focus in on writing linear equations specifically from kind of these word problems, these situations where the situation might be more described than you are explicitly given points or values like we were last class. And we're going to write in word problems in two different forms. We're going to mostly use slope-intercept form, which we should be really familiar with, and then standard form, which we haven't actually worked with quite as much, but we're going to use it for these word problem ones that we work with today. So just as a reminder, our slope-intercept form is y equals mx plus b. And when we're trying to write these equations in slope-intercept form, what can be really important is trying to look for some of those words that might mean slope and some of those words that might be y-intercept. So some dead giveaway words for slope. Per is a big one. Each comes up a lot. And then sometimes, you might have a word that means like a positive or negative slope, like some version of increasing. And then, of course, likewise, decreasing could mean a negative slope. So per and each are pretty big giveaways for slope, and then increasing, decreasing could give us a value for slope. Now, slope usually represents some kind of change, compares two values together, something per something, something each something. Our y-intercepts words, though, are typically a specific amount. Okay, so you might see something like initial, because it's that very first value, start, beginning. So any sort of word that might kind of indicate that this is like a starting charge, an initial charge, a first charge, or first value given a situation. Okay, so we're going to keep those kind of words in mind, and we're going to use them to kind of try and interpret these word problems and then actually write an equation that we can use. So number one, we are going to New York. You are currently on the runway. When the plane takes off, it rises at 1,500 feet per minute. Now, when we're trying to understand these, it can be really important to kind of define your variables first. Okay, our independent variable, if we remember, represents x typically, and our dependent variable represents y. And there'll be very rare cases where that won't occur, but 99% of the time, independent is x and dependent is y. Okay. So there's two things that we have. We have this plane, and it's rising height, so some feet, that 1,500 feet, and then per minute, so some time is passing. So we're trying to track the plane's height over the time or the minutes. So trying to determine which one should be x and which one should be y. Our independent typically is time. It's that thing that we're not necessarily changing. It's just going to pass on its own. It's independent of the other value. So I think minutes in this case makes the most sense for our independent variable. And then our dependent variable, what's going to depend on the minutes as they go by? Well, the height of the plane is going to depend on that. Okay. Then our starting value, which remember our starting value represents our y-intercept. So our starting value, it says when the plane takes off. So if the plane is taking off, that means it's starting on the ground, and the height of the ground would of course be just 0. And then our rate of change, so remember we're looking for per each, or maybe increasing or decreasing. So we have this per word, so 1,500 feet per minute. So that 1,500 definitely represents our rate of change. And there's one other important piece here, and that's that it rises as 1,500 feet. So that rises, that kind of fits in that increasing realm. Rises means we're going up, which means our slope should be a positive 1,500 feet per minute. Okay, so if we have our starting value, we have our slope, we have everything to plug into our equation. So y equals m, which is 1,500, x and then plus our b, which in this case is plus 0, which we don't have to write, but for our notes, so it kind of makes sense, I'm going to add that in. Okay, and that's really all there is to it, y'all. Kind of dissecting and understanding the problem and then using all of that information to be able to write an equation. Now, we're going to be tracking, kind of plugging in some values, maybe making a table of values. So let's make a table for this one, which you could probably, plug in like for 1 minute, for 2 minutes, for 3 minutes, for 4 minutes. You could use our equation to kind of calculate those y values, but we can also use our calculator to make a table. So let's go to our TI-84 real quick. And if I wanted to use this calculator, I can go to my y equals. I can enter in my equation, so 1500. And I'm not going to add the plus 0 this time. And then I don't care about my graph as much as I do my table. So if I hit the second button and hit graph, it's going to take me to that table window. And you can see right here, I can get that first set of values. So 0, 0, 1, 1500, 2, 3000, 3, 4500, and so on and so forth. So I can just take that table and I can plop that in right here. So 0, 1, 2, 3, 4, and we had 0, 0, 1, 1500, 2, 3000, 3, 4500, and 4, 6000. So writing these equations is going to really rely on some of those skills without the calculator. But then if we wanted to find values, if we wanted to utilize these equations, that's where a calculator can really come in and kind of be a tool for us. Okay, so let's look at another one. Let's look at number 2. So a hot air balloon is currently at 200 feet and is preparing to land. The balloon is descending at 5 feet per minute. Okay, so once again, we have this object in the air. It's some sort of height in feet, and then time is passing. It looks like in minutes. So I think just like last time, we can do our time as our independent variable. And we can do our height as our dependent. And then our starting value, they tell us that it's currently 200 feet in the air. So that definitely sounds like our y-intercept. And then they tell us it's descending at 5 feet per minute. So that feet per minute, that's definitely our slope value. So 5, but the descending means it should be a -5 slope. So we have everything we need to go ahead and write our equation. So y is equal to -5 x and then plus 200. Okay, and once again, if I wanted to fill out the table, I can use my TI-84, or we talked about our Desmos calculator. I'm going to show you how to do it in our Desmos calculator as well. So if I want to do my Desmos calculator instead, right here, in my, I'm using the wrong calculator though. So in my Desmos calculator, we can do y equals -5 x plus 200. Okay, and you might see my graph is off the screen, which makes sense. It's pretty big. I can, of course, the nice thing about the Desmos calculator is kind of with your hands, you can get your window adjusted. Okay, but if I want to turn this into a table, I'm going to hit this little gear right here, and I'm going to hit the table button right there, and it's going to automatically transfer that over into a table. Now you might notice mine doesn't start at 0 this time. It goes -2, 0, 1, 2. So if you want to, you can always change that into a table that fits for us better and just retype these x values, and it will automatically calculate the y value for us. So 0, 1, 2, 3, 4, and we can see those y values of 200, 195, 190, 185, and 180. So just filling that in, 0, 0, 1, 2, 3, 4. Sorry, not 0, 0, 0, 200, and then 1, 195, 2, 190, 2, 190, 3, 185, and 4, 180, and so on. Okay, so relatively straightforward, nothing too crazy, nothing too difficult. Let's look at another one together, number 3. So you go to the orthodontist because you need braces. He tells you that you will have to pay $300 today and $100 a month until you are finished with your treatment. Okay, so we have our x variable and our y value. Remember, x typically represents the independent variable and y typically represents the dependent variable. So we have two things happening. We have cost, money of our braces, and then our month, it looks like, is our time. So once again, I think our time and month should be our independent. And then our dependent is going to be our cost. It looks like it's in dollars. Okay, so our initial amount, what are we going to have to pay today? So that you will have to pay $300 today. So up front at the very beginning, we are paying that $300. So that is definitely our y-intercept or our initial amount. Okay, and then we're paying $100 a month. So $100 a month. Remember, our y is representing the cost of the braces, so that cost is going to go up. So that $100 is going to increase a month. So that is definitely our slope right here. $100 per month. And then adding that into our equation, we get y is equal to 100 for our slope, x plus our initial value of 300. Okay, so writing the equation, very similar to the last two. Okay, now let's talk about what's in that box. If your treatment lasts 18 months, what is the total cost? Okay, so now I'm asking you to kind of use a value to actually plug into our equation and calculate for something. Okay, so that 18 months, that's representing our x value, which means if I want to use that 18, I'm going to plug it in for x in my equation. So right here, this is going to become y is equal to 100 and 18 because it's going in for x plus 300. And I, of course, can plug this in the calculator if I need to. I can also just multiply this on my own. 100 times 18 would equal 1,800 plus 300, which would equal $2,100. So relatively straightforward. And of course, if you need to, you can type that 100 parentheses 18 plus 300 directly into your calculator to calculate that value on your own. Okay, I've shown you a bunch. I want you to try and go ahead and do number 4 completely on your own. So you're trying to call an Uber, but they're in surge price mode. You're going to be charged $2.80 plus $1.60 for each mile traveled. So go ahead and fill out your information and write your equation, and then use that information. You only have $10. How far can you go? Okay. All right, y'all, let's go ahead and check our work on this one. So we have our Uber, it's in surge price mode. We're going to be charged $2.80 plus $1.60 for each mile traveled. So we have two things happening. We're traveling in miles and we're being charged money. So that distance in miles, I'm going to travel whatever I'm going to travel, but my cost is going to be dependent on the miles that we're traveling. So that distance in miles is definitely going to be our X, our independent, and that Y, that cost in dollars, is definitely going to be our dependent. We have two things happening. We're charged $2.80 right up front. We're going to pay that $2.80 no matter how far we go. So that's definitely our initial amount. And then we're getting $1.60 for each mile traveled, so that each definitely tells us slope and it is going up. So it's going to be a positive $1.60. So our equation is y equals 1.60x plus 2.80. So relatively straightforward. Okay. Now, a little different than our last one, you only have $10. How far can you go? So this is important. This is why we define our variables in number 3. Okay. Our variable they gave us was months, which represented X, which is why we plugged 18 in for X. This time, our $10 is y, which is why I'm going to plug in $10 for y, and then solve for x instead of just being able to plug everything in. So solving for x, I can subtract 280 from both sides. That gives me 720 is equal to 1.6x, and then dividing both sides by 1.6, we get x is equal to 4.5, and then that would be in miles because we're trying to find how far we can go. With that $10, we can only go 4.5 miles. Okay, so really important to pay attention to when I'm asking you to solve, when we're kind of going to that next step, that you know which variable to plug into. Okay, we're going to transition a little bit. So all of those were slope intercept form. Now we're going to work with standard form. And standard form is a little bit different. Okay, it is ax plus by equals c. Oop, wrong tool. So ax plus by equals c. And what's a little bit different about this one is that A and B are kind of similar in what they represent. They just represent two different variables. Okay, so A is typically the amount slash cost of X. So some sort of number or amount or cost associated with my variable for X. And then B is the exact same thing, but for my variable Y. So whatever it is for A, it's associated with X. Whatever it is for B, it's associated with the variable for Y. And then my C always represents a total. So whatever it is that X and Y is trying to represent, C is always that total. So when we're thinking of some words that might represent these various things, so A and B kind of have very similar words. They could be each, they could be the value of it, they could be the amount, some kind of specific cost. They usually you'll see them associated with two different variables, and we'll see when we read the word problems, they'll sound very different from our slope intercept ones. Okay. And then of course our total words a little bit different. A lot of times you'll literally see the word total. Okay, you might see together. Same thing, amount or cost. So sometimes you might see these together, total amount, total cost, the value together. But it really kind of tries to represent that we have two different things that are both changing that we're adding together to get a total. Okay, so let's look at an example. So on number 5, a 100-point test has X questions worth 2 points apiece and Y questions worth 4 points apiece. Okay, and the first things that we want to kind of note is, what do our two variables stand for? So we have two different things. That's the key. When we're using standard form, we have two different things that are worth different amounts or have different totals or have different costs. And in this case, we have X questions and Y questions, and they're each worth two different amount of points. So our X are our 2-point questions. And our Y's are our 4-point questions. And our total, all together with our X and our Y questions, it is a 100-point test. Okay, so those are really important. So we have an X amount, the 2-point questions, we have a Y amount, 4-point questions, and then we have a total. So this tells us we're working in standard form. So all I'm going to do is that amount for the X variable, I'm going to put in front of X. So 2X. And then the amount for the Y variable, I'm going to put in front of Y. So 4Y. And the amount for the total just always goes on the other side of the equal sign. And that's it, y'all. It really doesn't get any more difficult than that. The big thing is just, instead of looking for those slope terms like we were on the first page, this time we're looking for those two changing different variables that aren't necessarily related to each other. It's not a per or an each representing a slope. So let's look at another one. Let's look at number 6. Okay. Louise has $36 in $5 bills and $1 bills. How many of each type of bill does she have? Okay, so we have 2 different types of bills. We have $5 bills and $1 bills. Doesn't really matter which one you assign. I usually just go in the order of the problem. So we can say that our X is our $5 and our Y are our $1 bills, and our total is $36. So once again, we're just going to put that value of X in front of X. So 5 times X, and then value of Y. So 1 times Y. And that's equal to our total, which is 36. Okay. So hopefully we're kind of starting to get the hang of it. I want you to go ahead and do 7 on your own. Okay, so bakery sells muffins for $1.25 each and scones for $1.75 each. Their goal is to make $1,000. Write a standard form equation to model this situation. Identify your variables and leave the decimals in your answer. Okay, so go ahead and pause me, see if you can write this one on your own. All right, and just checking in to make sure we're all good to go. So we have 2 different things, our muffins and our scones. Our muffins are $1.25 each. Our scones are $1.75 each. So I went ahead and said muffins are X and scones are Y. And then our total, their goal is to make $1,000. So our X value in front of X, so 1.25X. Our value of Y in front of Y, so 1.75Y. And then those added together are equal to our total, which I forgot a 0. So equal to 1,000. All right, and that's really it, y'all. These writing from word problems, some people find them a little easier than the ones we did last class because they are working with real things, with real variables. But they're pretty straightforward and they really follow these patterns. So good luck practicing.